Hello guys, I hope you are doing good. Welcome to the fourth video in the series. Today we are going to solve the piping question. This question was asked in Amazon's interview. If you see the problem statement, we are given a nested object and the object at any level can have function as a value. We have to implement this pipe function. Pipe will take the object as input. It will return another function. That return function will accept arguments. This arguments count will be equal to the number of arguments that the functions are accepting, the maximum count. These objects function can have these arguments count or less than that. It cannot have more, so we are accepting the arguments as the maximum value, and then we'll be passing these arguments to these functions which are as values, and whatever is processed will be storing that value in the output. So if you see 111 is passed to the object with the key b, which has the function, and here after processing 1 plus 1 plus 1 becomes 3, so at b we got 3 as a value. We will have a nested object. It can be of any level, so we have to handle that. Let me copy this sample from here. As you can see, with JavaScript it's not a DSA, so we cannot have the standard input and output through the terminals, so that's why you have to use the sample test cases to test or evaluate your code. So I've copied that, and now we have the object. Let me create the pipe function. So reading the problem statement, pipe will accept arguments which will be object. This can be nested, and then it will return a function. This function can have any number of arguments. It will be the maximum what these functions are accepting. It can be less than that, but it cannot be more than that. So assume that, and based on that we are accepting the arguments over here, and then I'm going to iterate over the object. So let object in the key. Here I'm not adding any additional check to see if the key is part of the current object or its prototype chain, but it's good, and if you want you can add it. And now here let me get the value. So object dot key value. I am using the for in loop. That is because once we have found that this value is of type function, we have to update the value at this current key. That's why I'm using for in loop. And here let's add a condition. If type of val equals to function, then what we are going to do is we are going to update the value of the key, and that will be by passing the arguments to this function. Because this value is of type function, we are spreading the arguments that we have accepted over here, and whatever the computed value will be from this function, we'll be storing that at the given object key position. Otherwise we'll have another check. If type of val equals to object, so we are only going to recursively call this function if the type of val is object, and here we are going to have this object that key, and to this will recursively call the pipe with the current object, and to this we are going to pass the arguments because pipe returns a function. And then finally, because pipe must be returning a value which will be stored at this key, so inside the return function at the end we are going to return the processed object with the updated value. With this our pipe function is ready. Now let's test this. If I run this code, we should have a b object unexpected identifier. See what happened. There was a spelling mistake on the variable declaration. So if I run this, you can see output, we are getting the desired output. After computation, B has value 3, C has 1 and D has -1 as we are seeing in the output. Let's update this a little bit. Let's have all other types. So let's E equals to 1 numeric type, F equals to true a boolean type, G becomes a string, and then H becomes an array. So the computation is only on the nested objects, not on any other types. So this should be unharmed or unchanged, and if I run this, we should have this value as it is. So as you can see, E has 1, F as true, G as the string alpha, and H with the array, whatever we have passed. So the computation is only happening on the nested objects. Let's say if I have L over here, and this will become object M, and to this we are again passing this function as it is. Then the M should also have 3 as the output. So see, we are getting M and the value as 3. So this is how you can implement the pipe function. Pipe has many variations. There are at least 4 variations depending upon the level. So pipe, this is for SDE1, pipe 2 is for SDE2. Then there is pipe 3 and pipe 4, which is for SDE2 senior and SDE3. All those 4 variations are available on my course. So if you are preparing for front-end interviews, do check it out. Thank you. I'll see you in the next video with the next question, method chaining.